Alright, so here what we're doing is we're testing cars. We got like 10 cars. Um, and we're trying to see if gas mileage changes when using premium gas as opposed to using regular gas. So we got to test the hypothesis, check a 90% confidence interval, and then we got to answer the question. So let's see what happens here. So let's do A and B. We'll start out with those. So we're going to test, so we're going to do a hypothesis test. So mu of B is the mean difference in gas mileage of a car using premium versus regular gasoline. And then the hypothesis, the null, of course, is that mu of D is 0. Now, here's what I want to happen. I want to see when I use premium gasoline, I want the gas mileage to increase. Okay, so I expect the gas mileage to increase. So I expect it to go up. Okay, and then the assumptions and conditions. Well, this is paired data because each car is doing both. This is a paired test. So I believe we randomized this. We randomized the order of which car will receive premium first, right? So we randomized the order. 10% condition, 10 cars. It's less than 10% of all cars. And then we got to check the normal condition, right? So here you go. There's the data. There's regular in L1, premium in L2. So I'm going to go to L3 and I'm going to do L2 minus L1. And those are the differences. So it looks like they're all positive. That's good. And I'm going to go to plot on. I'm going to go to my histogram for L3. I'm going to go to zoom stat. So look at that. That's roughly unimodal and symmetric. So that gets copied on your paper. So the histogram is roughly unimodal and symmetric. So you can put that down. So the histogram of the differences is roughly unimodal and symmetric. Now on your paper you should have the histogram drawn, but I'm not drawing it because of time's sake. Okay, so name test, we got a match paired t-test. Okay, test statistics. Okay, so let's go. Stat, calc, 1 var stats for list 3, right? And we're going to get an x bar of 2 and a standard deviation of 1.414. So x bar is 2, standard deviation of the differences, x bar should be 1.414, n is 10, degrees of freedom is 9. Okay. Obtain p. So we're going to do x bar minus mu over s divided by the square root of n. Okay. So this time we're going to let's go to stat test, t-test, and again my mu is 0 because the difference is hypothesized to be 0. I'm in list 3. I'm looking for greater than, and I got to draw that out. And I should get a p-value. Let's see what we get here. Here it comes. So we got a p-value of 8e to the negative 4. And a t-value of 4.47. Okay, so t is 4.47 and p is 8e to the negative 4, so that's 0.0008. 3 zeros. So make the decision, reject H sub O at the 0.05 level. And the conclusion is there is strong evidence that gas mileage increases when a car is run on premium instead of regular gasoline. Okay? So now we got to do the confidence interval. That's what question B asks for. So we're going to do X bar plus or minus T with 9 degrees of freedom. S is 1.414 over the square root of N. So that T value right there, if I was to do a 90% interval, right, that T value, this is 90%, then this starts at the 5th percentile and ends at the 95th percentile. So I'm just going to get that T value, inverse T of 0.95 with 9 degrees of freedom, and that T value should be 1.833. So I like to put that in there. And I'm just going to calculate that. So let's go to stat, test, T interval. And again, we're going to use data from list 3. Confidence level is 0.9. Calculate. And 1.2 to about 2.8, right? 1.2 to 2.8. So we are 90% confident that gas mileage increases between 1.2 and 2.8 miles per gallon when a car is run on premium instead of regular gasoline. Okay. So the next question says, well, why might a company not choose to do that? Well, that's obvious. Dollars, right? May not be worth it to do that because you're only increasing gas mileage between like 1 and 3 miles per gallon. So the company may just say, you know what, I'm not going to pay that extra dollars to do that. And then the fourth question says, well, what would have happened if you had done this as a 2-sample test? So if I did this as a 2-sample test, okay, and let me go to 2-sample t-test, and my data is in list 1 and list 2. And remember, list 1 is regular and list 2 is premium. So I expect my list 1 to be less than, okay, and then I draw that. What would have happened look at that. Okay, so what's going to happen? We're going to have a larger p-value. So we get a p-value of 0.1144. So we would have failed to reject it. So if we had done a 2-sample t-test, we would have failed to reject it, and we would have come to the conclusion that premium gasoline doesn't improve gas mileage, when in fact it does. So we would have come to the wrong conclusion, and that's the answer to D.